In this circuit, the first important block is the 555 timer IC. It is configured in astable mode, which means it continuously generates a clock signal without any external trigger. The resistors of 1 kiloohm and 2 kiloohm, along with the 47 microfarad capacitor, decide how fast the output toggles between high and low. The capacitor charges and discharges through the resistors, and the 555 compares this voltage with internal reference levels. Every time the capacitor voltage crosses these levels, the output changes state. This creates a square wave at the output pin of the 555. The small 10 nanofarad capacitor connected to the control pin helps reduce noise and keeps the output stable. Overall, the 555 timer acts as a simple and reliable clock generator for the rest of the circuit. The square wave coming from the 555 timer is used as a clock signal. This clock decides the timing of the entire circuit. Each pulse represents one step in the sequence. As long as the 555 keeps running, clock pulses are continuously produced at a fixed interval. This regular timing is very important for digital circuits because it ensures predictable behavior. In this design, the clock signal is fed into the next block, which is the shift register. You can think of the clock as a heartbeat. With every clock pulse, the system moves forward by one step. By adjusting the resistor or capacitor values in the 555 section, we can make the sequence faster or slower, which directly changes how quickly the LEDs shift. The next block is the SIPO register, which stands for Serial in Parallel Out. This register takes in data one bit at a time and outputs it across multiple pins. With every clock pulse from the 555 timer, the data shifts from one output to the next. In this circuit, the outputs of the SIPO register are connected to LEDs through current limiting resistors of 330 ohms. As the bits shift inside the register, the LEDs turn on one by one in sequence. This creates a running light or chaser effect. Even though the input data is serial, the outputs are available in parallel, allowing multiple LEDs to be controlled at the same time. When we look at the complete circuit, the working becomes very clear. The 555 timer generates a steady clock signal. This clock drives the SIPO shift register. With every clock pulse, the active logic level moves to the next output of the register. As a result, the LEDs light up in order, creating a visual sequence. This type of circuit is commonly used in LED chasers, running lights, signboards, and simple display systems. The design is easy to understand and very effective for learning timing and digital logic concepts. By changing the clock speed or the number of LEDs, different patterns and effects can be created without changing the basic structure of the circuit.